So welcome to my channel. It's Osemka Lorima speaking. Today we'll be looking at empirical formula. We'll be looking at empirical formula. So empirical formula of a compound can be defined as the simple formula which shows the ratio of the number of atoms in one molecule of it. So we'll be solving some examples under empirical formula. So the first example we're going to be solving is this example one. This says a compound contains 43.4% sodium, 11.3% carbon and 45.3 percent oxygen. Calculate its empirical formula. So we have to calculate the empirical formula. So let's start. As sodium equals Na, that is sodium, which is equals to 23, a carbon, which is equals to C, equals 12. So we're writing out the relative atomic number of all these of the elements, and oxygen equals to. So now we're going to be using the percentage composition. The formula for this, like how we're going to be using for this, uh, how we're going to solve it. We're going to do it like this: the percentage composition of the elements divided by the relative atomic mass of the relative atomic mass. These are the relative atomic mass here. So we're going to do it like this: percentage. The formula for that is percentage composition over relative relative atomic mass. So we'll be taking the percentage for each of the elements one by one. So the percentage for sodium is the first. For sodium is 43.4%. So over the relative atomic mass. So the relative atomic mass for sodium is what? That is 23. It's 23, yeah. That's it. So now this is for sodium. So now we're going to this for sodium. Let me put it beside it. Sorry. Equals to 43.4 all over 23. So now for oxygen, for carbon is the next. We have to follow it respectively. So for carbon equals to the relative atomic mass for carbon is the percentage composition for carbon is for carbon. sorry, is 45.3. That's is 11.3, sorry. 11.3. So all over the atomic mass. The relative atomic mass for carbon is 12. So 12. So now we're going to go for oxygen now. Oxygen equals, let's go. Oxygen equals equals 45.3. Percentage composition is 45.3 all over the relative atomic mass, which is 16. Yes, 16. So now I'm going to divide this 43 divided by, so let's go now. So let's divide this 43.4 divided by 23 for sodium. For sodium equals to 1 point, when you use your calculator, dive out to be just 1.89. For carbon, see, for carbon, when we divide it, it gives us 0.94, 0.94. And for oxygen, we have 2.83, 2.83. We have 2.83. So now guys, to do this, we're going to divide these we're going to divide each of these elements. So we'll look at the one that has the smallest value. So carbon has the smallest value, so we will divide all by 0.94. So Na now will be Na equals to 1.89 all over 0.94. And now our carbon will be equals to 0.94 over 0.94. So our oxygen now will be equals to 2.83. This is our oxygen here, 2.83, 2.83 all over 0.94, 0.94. So now guys, when we divide it, our answer will be Na Na will be equals to, our sodium will be equals to 2 when divide it, carbon equals to 1, and oxygen will be equals to 3. So now our empirical formula for this example, for this is our empirical formula equals N. So the answer for this, the answer that we got for sodium, carbon, and oxygen will be the subscript for each element. So the value for Na is 2. So the subscript Na. So bring the 2 to the as the subscript. Na2, our C is 1, so C O C oxygen 3. So our Oxygen is 3, so the subscript will be 3. So this is the empirical formula for this question 1. So let's go to the next question, example 2. Example 2. This question says a substance contains 25.3% magnesium, 73.7% chlorine by mass. What is its empirical formula? So let's solve this. So now workings. So as we all know, the formula is percentage composition. As we all know, it's a percentage composition all over relative atomic mass. So our percentage composition for magnesium equals 25.3%, and our chlorine equals equals 73.7%. So now we have to find the empirical formula as usual. So let's bring out its let's bring out its relative atomic mass. This is our percentage composition. We need our relative atomic mass. So the relative atomic mass, relative atomic mass Ca, magnesium, sorry, it's magnesium, which equals to 24, and chlorine equals 35, 35.5. So that is it. So now let's solve it. So now we're going to bring out for magnesium now. For magnesium, the percentage composition of magnesium is 25.3 all over the relative atomic mass, which is 24. For chlorine, the relative the percentage composition is 73.7, 73.7, and the relative atomic mass all over the relative atomic mass, which is 35.5. So now guys, let's divide it with our calculators. So mg equals 25.3 divided by 24. That will give us 1.05. And for our chlorine, 23.7 divided by 25.5 will give us 2.10. 2.10. So let's do so now, as we all know, we're going to divide the answer of this by the smallest value. So which is the smallest value? Magnesium 1.05 is the smallest. So let's divide each by 1.05. D equals 0.05 over 1.05 chlorine equals 2.10 over 1.05. So 1 point mg are mg now equals 1, and chlorine equals 2. So our empirical formula for this empirical formula for this empirical formula equals to our magnesium is 1, so we have one subscript for magnesium Mg, and chlorine we have 2 for chlorine, so our subscript for chlorine is 2. So this forms magnesium chloride. So thanks for watching, guys. Please subscribe to this channel. Subscribe. Subscribe to this channel. Don't forget to give a like to this video and share this my video. Subscribe and share. Thanks for watching. Thanks. I still remain a same casually man. Thanks for watching. Bye. See you in my next video.